and this is the analytics window of the mouse cursor. This graph shows the speed of the mouse cursor. When I move the cursor, the graph will be changes, and this block shows the color of the position at which the mouse points. Okay, I will point here, it will be shown gray. I will point here, it will be shown green. Okay, the color of the position. Okay, and here blue, and this block will shows whether the mouse is active or not. When I don't touch the mouse cursor, it will be inactive. When I move the cursor, it will be active. And this block shows the position of the cursor. Okay, when I move the cursor, the position also will changes from here 0,02 and 136 1365767. Okay, and let's dive into the tutorial. Okay, here import the necessary libraries to the Python. Okay, these are the common libraries I have imported: math and collections and time. And this library is used to take the positions of the mouse cursor and the color of the position at which the mouse points and this data, and we calculate the speed based on the position. Okay, we have many libraries to take the cursor position, but I have chosen the xlib because it is speed, it is faster than other libraries. Okay, it executes faster than other libraries. Okay, it gives the cursor position accurately and fastly, so I have chosen this library. And as you know, this is the matplotlib to plot the graphs and to plot the speed of the cursor, and this is used to act as a backend. Okay, we are using the GUI platform Kivy, and we want to integrate the matplotlib into the Kivy app. So we are linking the backend. We have the Kivy backend to the matplotlib. We are linking the Kivy backend to the matplotlib library framework, and these libraries, these are the widgets we are importing for the GUI window. Basically, we are importing the Kivy app and a layout and a label and a button and a clock to update the graph and choose an interval. Okay, and this is used to import the backend. This is used to plot the graphs. Okay, and struct is used to convert the regular expressions into a integer format. We will use it. Okay, we will see. Okay, after importing the libraries, okay, basically we want to calculate the speed of the cursor and the speed of the cursor and position of the cursor. Okay, first we want to take the position of the cursor. We have the direct syntax from library to take the position of the cursor. These are the two lines. Okay, we will discuss about it. Okay, this function and is used to calculate the speed of the cursor. Okay, when I place the cursor here and move the cursor to here, the speed will be calculated from initial position to final position. Okay, and the speed will be displayed. Okay, the speed as the screen is in pixels and the time will be in milliseconds. So we are converting the speed into miles per hours. Okay, so we are assuming 100 pixels into inch. Okay, actually 1 mile equal to 63360 inches. Okay, then again we are converting 1 inch into 100 pixels. Okay, you want to change the in pixels to inch conversion into any number, you can replace this number into another number. Okay, right. And this pixel to mile ratio will be 1 mile equal to 633,600 pixels. Okay, as we are assuming 100 pixels per inch. Okay, then we are pixels to miles, we are using the function. Okay, as we want to convert the pixels into miles. Okay, when I will give the 100 pixels, it will be divided to the ratio, then it will be converted into miles. Okay, right. And we are using the collections to name a tuple like x, y, z. In this, x is the x-axis, y is the y-axis of the position. When we place the cursor, we will have a position x comma y. The x comma y will be the this x comma y tuple, and z will be the time. Okay, just we are naming the variables into a tuple. That's it. Okay, it will be easy by using the tuple. So we are named it tuple. Then we are using a function called calculate speed. Okay, the sample one is the initial position of the cursor, and sample 2 is the final position of the cursor. Okay, actually when the 2 points x comma y, x1 y1 and x2 y2, the distance will be square root of x2 minus x1 whole square plus y2 minus y1 whole square will be the formula. So as per the formula we have implemented using the math library. Then we are converting it into hours. Okay, now we are getting the distance, we are getting the distance. To calculate the speed formula is distance by time. So we have the distance, next time equal to, we have the tuple, in one tuple there will be x and y, the positions, and z will be the time. Okay, we are subtracting the final time to initial time. Okay, it will be in milliseconds. We are converting into hours by 33,600. Okay, then as we have hours, and the distance will be in, after using the formula, we will have the distance in pixels. Okay, we should convert the pixels to miles, so we are converting the distance into pixels to miles by using the pixels to miles function. Okay, after converting it, actually this is the distance and this is the time. Distance by time will be the speed. Okay, we are writing an extra condition here, because if by mistake, if initially the time will be 0, so if we get 0, we will get a float division error. Actually a number cannot be divided to 0. So if hours not equal to 0, only if hours is not equal to 0, the formula will be valid. If hours equal to 0, then it will be, the whole value will be 0. The whole value will be 0. Okay, then we have the function of calculating the speed. Okay, then we are plotting a graph. Okay, and we are inserting it into a canvas. Okay, it's fig.canvas is the canvas object to draw. Okay, and as we are creating the canvas object here into a canvas variable. Okay, and we are creating a Kivy app. Okay, if you do not understand this, you go to search and search the Kivy about Kivy. Okay, to know about this tutorial, you should know basic about Kivy. Okay, and we are creating basic Kivy here, and in this build we are creating a layout. Okay, one horizontal layout, one okay, two horizontal layouts and one vertical layout. Okay, the graph box is an horizontal layout to picture the graph. Okay, yeah, and the size is 1 comma 0.8, means it occupies the 80 percentage of the window. As we have seen before, it will occupies the 80 percentage of the window. You may change this to graph occupation here. And the second one is the widgets box, and we have the three widgets, like one is to show the color of the position, and one is to show whether it is active or not, one is to show the position of the cursor. So the three widgets will be in this widgets box. Okay, it will occupy the 20% of the window. Okay, I will run and I will show them. This is the graph box, and these three are the widgets box. It takes 80% of the window, and these two take the 20% of the window. Okay, you can change. I will change the 0.5 and 0.5. That the two addition should be 1. Okay, it should occupy the whole window, and I changed it. Okay, once you will see. Okay, it has now 50%, and here 50% of the window occupied. Next, so I like the 80% and here 20%, so I will change it to, and that total box is the vertical box. To add this graph box widget box into total box. Okay, this is the main layer. Okay, then this is the time to calculate. When I run this run this program, it will take the initial time. Okay, it will be in seconds, and it will be in seconds based on the local time. Okay, it takes the local time of the computer and calculate it into seconds. Okay, I will take initially time as a 0. Okay, when I will start the application, the time should be 0. Okay, it will be started in like timer, when we will start the timer at 0 seconds. So we are initializing the time to 0. Then these are the two lines that are used to um, take the position. Okay, position of the cursor. Okay, this data one is the display. It takes from this xlib library. Okay, we are using from here. Okay, from display we are taking the data one. In this data one we will have the position of the cursor. Okay, data one of root x and data one of root y. Data one of root x will be the x position, and data one of root y will have the y position. And this is the time we have put initially 0. Okay, and we are inserting this 3 variables into a tuple, as we have initialized here. Okay, as we have initialized here, we are inserting the 3 variables into tuple sample of, and we are naming it as sample1. Okay, initial tuple which will have 3 data, x, y and time. Okay, we are using the as we want to give the input 2 tuples. Okay, we should give this calculate speed function 2 tuples. Okay, initially here we are calculating the speed into a speed variable. Okay, we are using the calculate speed function, but initially we'll have we'll have only initial position. We will not have final position, as we don't know the final position. So firstly we are calculating with the initial position 2 times. Okay, to take the initial speed. Okay, we should calculate, or we can take the initial speed as a 0. It's our wish. I have calculate the initial speed by taking the same tuple. Okay, same position, same initial position, we are calculating the speed between initial position and I in the same position. Okay, and we got the speed and we got the speed and we got the time. Okay, we got the speed and we got the time. Okay, to plot the graph we have to move these variables into array. Okay, so we are defined an array, time array. So we have included the time variable, and we have defined the speed array and included the speed variable. After assigning the variables, we have now time and speed. Now we are creating the button and labels. Okay, button with no text. Okay, actually we do not have to button. This button we are using to change the color widget, the color of the position with the mouse points. Okay, the color will be changed. Okay, as we are choosing the button widget because button has the option to change the color of the widget. So as label has no option like that. Okay, and this pose label is the label widget. We are creating the label of text equal. This is the label widget. We are formatting the this X position and Y position to that widget. Okay, we are using this text. Okay, we are formatting these two variables into here. Okay, and this is the stat label to show the status. Okay, just created the text and the size. Okay, the text will be updated in the below function. Okay, I will show you. These are the initial widgets we are creating. Initially this function is the initial layout. Okay, when we start the application, initially what we will see is this is the function we are seeing here. Okay, after creating all variables, we are adding the widgets. We are adding the canvas variable to the graph box. Actually we have the canvas. Okay, this canvas widget will have the graph. Okay, so we are including that graph into the graph box layout. Okay, we are adding the position label and the color of the position widget and the status widget. We are adding these three widgets into widget box. Okay, widget box, and after adding these two widgets, we are adding the graph box and widgets box into total box into a vertical layout. Okay, to complete the layout. Then here after here we are updating the widgets. Okay, this clock is used to this clock will update the graph, update the whole window, total window, by using this function. Okay, it will call this clock. Okay, this function activates the self.update function here. Okay, at every interval of 0 seconds. Okay, you can change the interval to 1 second, or you want to change the graph and other events very fastly, so put here 0. Okay, you can change the interval here. Okay, it will call the update function every 0 seconds. Okay, the speed of the graph and other functions will be based on your CPU power. Okay, based on the requirements of your system. Okay, so and we are returning the widget here. Okay, total widget we have created. Here we have the update function. Okay, this clock will regularly calls the update function. Okay, at an interval of 0 seconds you can change this interval. Okay, and here we have the update function. Here the update function will update the position of the update function updates the position of the cursor and the color of the position it with the mouse points, and whether the mouse is active or not, and the speed of the cursor. Okay, I will tell this um, I will tell about this code snippet at last. Okay, first we are plotting here. Here we have the time array to calculate the time, initial time, and we have the speed array. Okay, in this time array the times will be stored. Okay, enter at a interval of 0 seconds, and the speed of the cursor will be stored at a interval of 0 seconds. Okay, these two arrays will be plotted. Okay, these are the stylings of the plot. You can change here. Okay, and here these are the titles and XY axis titles and the XY axis coordinates, XY axis sizes and their positions. Okay, and here initially we have put here the start time. Okay, initial time when the application has when the program is executed, and here is the end time. Okay, when I place the cursor here, it has the initial start time. Okay, when I place the cursor here, it will have the end time. Okay, end time will be here noted. Okay, the timer will be end time minus start time. When we minus the end time, when we subtract from end time to start time, we will get the time. Okay, when I execute the program, okay, we'll start the time from 0 seconds to and so on, 0 1 2 3 4 and so on. Okay, here data 2 and sample 2 are the final. Okay, we have taken here the initial samples. Okay, initial samples of the position x5. Okay, we are taking the final position of the samples here. To update the samples here, we have put here. Okay, we have the samples x, position y, and the time. Okay, here the time is taken from here. Okay, and data 2 will take the final cursor positions, and it will be packed into a tuple. Okay, the tuple will be sample 2, and we are calculating the speed. Okay, that is sample 1, self.sample 1 is the initial tuple where we have placed here, and here sample 2 is the final tuple here. Okay, we are calculating the speed from initial position to final position, and we are storing it into a speed variable. Then for every initial and final position, final will be initial and the new position will be final. Okay, when I placed here, it will be initial. When I moved here, it will be final. Again I will move from here to here, so this position will be initial and this position will be final. And when I move from here to here, this will be initial and this will be final. When I move from here to here, this will be initial and this will be final. So final will be changed to initial. So actually sample 2 is the final, so we are storing it into a sample 1. So the final position will be initial position, and then new position will be a final position. So every time the update executes, the sample 2 will be the new position. Okay, and it will be interchanged. Okay, these 3 lines are to take the color of the position. Okay, this raw data will be in the xlib format. Okay, in the xlib format we will extract raw data. In this hex color we will have the hexadecimal values. Okay, I will show it. Print of hex color. Okay, I will execute it. As you can see here, we are getting some binary format. Okay, when I move here, move my position to the black color, it will be all zeros. Okay, so we want to convert this format into RGB format. So we are using the we are using the struct to unpack the that format into a RGB. So we'll have the RGB values into the get color. Okay, we'll have the RGB and A. Okay, and we have the speed array which will be plotted. So we should append the new speed variable to the speed array. Okay, the new speed variable will be appended here and the new time variable will be appended here. Okay, so the plot will be updated. Okay, and this line is to update the position label. Okay, taking from the data2 variable. Okay, we are taking the position x and position y to the position label, and we are updating the active or inactive widget. Okay, when we will know the mouse is active or not? When the mouse speed is 0. Okay, when I move the cursor, when I place the cursor here idle, okay, the mouse speed will be 0. So when the speed is not equal to 0, the status will be active and the color will be green. Okay, the label color will be green as it is active. And if it will be the speed is not equal to 0, the speed, if speed equal to 0, then it will be inactive. Okay, when I place the cursor here, the speed will be 0, it will be inactive, and the color of the label will be red. Okay, and this widget is the color of the position. Okay, we are updating color of the position by background color. Okay, by background color we are using the get color variable. We are using the get color variable, and we are extracting the we will get the RGB format 255 comma 255 comma 255. We want to convert that RGB format into the Kivy color format into zeros and ones. So I divided with their respective values and rounded it to 1. Okay, the 4 values will be updated here. Okay, and the 4 values will be updated here, and RGB and A actually put the A to 1. Okay, and this canvas draw function will update the graph. Actually after we getting the widgets values, okay, we will update to the canvas. Okay, we will update the graph to canvas. Okay, this canvas dot draw will update the graphs and the windows, update the graph. Okay, here this widget will update the position of the color of the position, and this will update the active or inactive status, and this widget update the position of the cursor. Okay, and this canvas dot draw will update the graph. Okay, so okay, now I will tell about this. Okay, as the array will be increased on time. Okay, after the array will be increased, the plot will be congested. Okay, I will show. I will clear this 4 lines. Okay, and I will run the graph. Okay, when I run the graph, I will move the cursor and the speed will be changed. Okay, after I move the cursor at a certain period, it will be congested here. Okay, it will not move here. Okay, it will not clear the axis. Okay, the samples will be added and the samples will be congested here. Okay, and so we want to clear this sample at a certain period of time. So these 4 lines will when the speed array, mean the sample speed samples, when speed samples will be greater than or equal to 70, then we will pop a sample, means we will delete a sample, we will delete the first sample. Okay, we will delete the first sample of the time and we will delete the first sample of the speed. Okay, then we clear the access. Okay, now I will like I will put here 10. For every 10 samples the access will be cleared, so we will see. Okay, so when I move here, we already get the 10 samples and the access is clearing here. As you see, for every 10 samples the access will be cleared here, the last sample will be cleared. Okay, for every 10 samples. So I will increase here, like I will increase for 50 samples, and for every 50 samples it will be cleared. Okay, 10, 20, wait for a period of time, it will be increased. Yes, it is clearing for every 50 samples, like as you said. When I put here mouse ID, it will be shown the 0 position, it will be shown the 0 position. Okay, right. I will put the code into the GitHub, and GitHub link will be provided in the description. Thank you. Subscribe for more videos.